You know that feeling when you're almost done with a huge project? You've put in countless hours, crossed off 100 tasks, and then you hit that final stretch. That last 1% seems to stretch out forever, feeling like the hardest part, often the most frustrating. We've all been there, right? Staring at a nearly finished masterpiece, wondering why the final details are so stubbornly difficult to perfect. Well, today we're diving deep into that exact phenomenon, specifically in the world of construction. We're taking a deep dive into what's known as the punch list. And this isn't just some informal sticky note of tasks. It's the critical, formal, final phase of any construction project. We'll define it, walk through its typical process, explore the common types of items it includes, delve into the human psychology and potential friction it creates, and then look at how modern approaches like the zero punch list and cutting-edge technology are transforming this crucial stage. Our mission today is to give you a shortcut to understanding how projects finish strong, how to avoid unnecessary friction, embrace efficiency, and truly master the art of, well, what we call true project completion. This isn't just about tidiness. It's about contractual obligations, financial closure, and ultimately delivering lasting quality.
Yeah, and what's truly fascinating here is how universal this concept is. I mean, while the term punch list itself is relatively modern, the idea the
Mhm.
idea of meticulous final inspection and rectifying imperfections before declaring something truly finished, that has deep historical roots. It really speaks to a profound universal human desire for perfection in craft, transcending eras and technologies.
Okay, so imagine the ultimate quality control checklist before a grand opening.
Yeah.
Or a friend of mine once put it like the final painstaking proofread of a Pulitzer-winning novel. Every single detail matters. That's the punch list at its core. It's that crucial moment where everything has to align perfectly, where the vision finally meets reality. And like you said, this isn't some informal scribble on a notepad. It's a formal, often contractually binding declaration of remaining work. It quite literally represents that gap between what everyone perceives as, say, 99% complete and what is actually 100% truly definitively finished. And the stakes here are pretty high, wouldn't you say?
Oh, absolutely. This phase is all about translating those abstract expectations and specifications from the plans, whether they're old paper plans or, today's digital models, into a tangible checklist for the physical structure. It's the moment of truth, really, aligning the initial vision with the final reality. And the very purpose of this stage, the crucial part, is its direct link to contractual project completion and, critically, the release of final payment to the contractor. That financial incentive is incredibly powerful. It drives the urgency of the punch list phase. Any delay here means financial repercussions for the general contractor who carries that financial liability for bringing the project in on time and within budget. It's the final gateway to getting paid.
That's incredible. And to think that this obsession with finishing strong isn't just a modern thing. I'm curious, have we always been so meticulous? Do we see echoes of this, like way back in history?
Yeah. Absolutely. The concept is ancient, really. Take the ancient Greeks, for example, masters of architecture. They were renowned for what historians call refinements, or these visual adjustments in Greek temple design. These weren't just big, obvious structural changes. They were often incredibly subtle optical corrections, like the entitasis in columns, that slight, almost imperceptible bulge in the middle. It makes them appear perfectly straight and robust from a distance. Or even the slight upward curvature of a temple's platform to counteract an optical illusion of sagging. These were all designed to achieve visual perfection. It shows a profound commitment to the final look and feel, ensuring the structure truly satisfied the eye. It's basically an ancient equivalent of a punch list, focused on aesthetic exactitude, but also on the perceived strength and balance of the building. They were fixing what the eye perceived as a flaw, even if it wasn't structural.
Wow. And it wasn't just the Greeks, was it? Even moving into the Middle Ages, we see this incredible meticulousness in craftsmanship and construction.
That's right. Fast forward to the Middle Ages, and master builders demonstrated incredible precision and a deep understanding of their materials. 13th century architects, for example, they were praised for designs that decidedly expressed both the return of the moldings and the weighting which it is necessary to give to these angles. Essentially, ensuring features like gable bases balanced their mass and were perfectly logical. This wasn't merely about superficial aesthetics, it reflected a deep logical understanding of structure and detail, ensuring both beauty and longevity. They aimed for, as one source puts it, no empiricism, no outward form without a principle. Every single element had a reasoned purpose, from the smallest molding to the grandest arch, and it had to be executed flawlessly to fulfill that purpose. That ensured both the structural integrity and the lasting visual harmony.
Okay, this is where it gets really interesting for me and so relatable. This obsession with the final touch. It's evident even in specialized crafts, not just grand architecture. It speaks to that universal desire for true perfection, right down to the smallest details. Can you give us an example?
Oh, a fantastic example comes from the world of early printing. Joseph Moxon, in his 17th century work Mechanic Exercises, meticulously describes how a printer would carefully works the outsides with proper files and smoothens and polishes the outside strokes and face with proper worn-out small watchmaker's files on typefaces. He's talking about literally filing and polishing the metal letters by hand. It's amazing detail. And then he goes on to explain that if the shouldering, that's the specific transition point where the letter's face meets its supporting metal shank, isn't filed precisely to an obtuse angle of about 100 degrees, the letter will, well, it will be smear the strokes of the letter, slurs the printed paper, and so makes the whole work show very nasty and unbeautiful.
Wow. Just imagine putting all that immense effort into crafting an entire book, only for one tiny, unpolished detail on a single letter to slur the printed paper of your entire effort. That's the punch list at its core, isn't it? It's ensuring that the very last details don't undermine the whole thing. It's a truly universal principle, whether you're building a temple or setting type.
Exactly. What these diverse historical examples reveal is a timeless truth. The perceived, functional, and even safety-critical quality of any complex endeavor ultimately hinges on the meticulous attention paid to that last 1%. It's not just about tidiness, as you said. It's about fulfilling a universal human desire for enduring quality and ensuring that the final output lives up to the grand vision.
So after we've seen how this idea of finishing strong has echoed through the centuries, let's bring it back to today's construction site. You're there, the scaffolding is coming down, the paint's drying, the bulk of the work seems done. How does this formal punch list actually unfold? You might imagine it's just a quick walkthrough, but it sounds like it's often a highly structured, almost ritualized dance involving several key players, each with a specific role.
Indeed, it really is structured. The initiation of the punch list begins with a formal walkthrough, a systematic inspection of the completed work. And it isn't just one person casually looking around. It typically involves key stakeholders. You've got the owner or their representative who holds the ultimate vision and financial stake. Then there's the architect who designed the project and ensures adherence to that design intent and the project's specifications. And of course, the general contractor who managed the construction and is responsible for the physical execution. Each party brings a unique perspective and set of responsibilities to the table, making it a comprehensive and often, well, intense review.
Right. And the purpose of this walkthrough, it's not just a casual stroll to admire the finished product, is it? It's a critical moment for accountability.
Not at all. No admiring yet. The objective is a meticulous inspection against the project specifications. These are the detailed documents, often hundreds of pages long, that establish the expectations for quality and contractor performance, and all work will be measured against them. These specifications are the primary benchmark for what constitutes a deficiency or an incomplete item, and every single identified item, no matter how minor it seems, is meticulously documented. Traditionally, yeah, this involved clipboards, paper, lots of notes. But as we'll discuss later, modern methods are rapidly digitalizing this. The documentation captures precisely what the issue is, where it's located within the structure, and crucially, who is specifically responsible for its correction. That level of detail ensures clarity and avoids ambiguity later on.
Okay, so when we talk about minor deficiencies, what does that actually look like on a construction site? Give us some examples of what commonly makes it onto these lists. It's often the small, seemingly insignificant details that can make a huge difference in the final feel, function, and perception of quality, right?
You're absolutely right. The types of items vary widely, spanning a spectrum from simple cosmetic fixes to critical safety concerns. We can broadly categorize them, though. First, you have cosmetic imperfections. These are often the most visible and include things you might expect, like paint touch-ups and minor drywall repairs where a seam isn't perfectly smooth or a corner isn't quite straight. But it goes deeper than just surface-level stuff. It could be ensuring elements like drywall are properly caulked, glued, or gasketed to top plate in areas like attics or behind wall panels. That's not just for looks, it's also to maintain airtightness and a clean, sealed finish. Any visible gaps or uneven caulk would certainly be noted. Or, for plaster ceilings, there might be requirements for control joints. These are essentially planned breaks that prevent cracking from shrinkage or temperature changes down the road. If these are missing or poorly executed, you're looking at future cracks that impact both appearance and longevity. That's a definite punch list item.
Okay. Then there are the things that just don't work right. which I imagine can be incredibly frustrating after all that work. Not just for the owner, but for the builders, too.
Precisely. And those fall under functional deficiencies. We're talking about things like malfunctioning hardware. A door that sticks when you try to open or close it, a window that doesn't latch properly, a cabinet hinge that sags, or even just a light switch that doesn't activate the light. On a more structural level, consider the proper installation of hollow metal door frames. It's vital as they may be fully grouted with mortar or plaster for structural rigidity and increased fire resistance. If that crucial step is overlooked, the door's function, its structural stability, and its specified fire rating are all compromised. That's a major functional and safety concern that absolutely belongs on a punch list.
Right. And then I'm guessing the most serious category involves anything that impacts the building's core safety and performance, making sure it actually meets essential standards.
Yes, exactly. The most critical category involves code compliance and performance issues. These are definitely more serious, impacting safety, usability, and the long-term performance of the building. This includes things like ensuring all egress requirements are met, like having the minimum number of exits or access to exits per story for safe evacuation. That's non-negotiable. It also covers fire resistance, verifying that things like wall and partition assemblies actually achieve their specified 1-hour fire resistance rating. This could involve checking the correct type and thickness of gypsum wallboard used, or making sure fire-stopping details are properly implemented around pipes or conduits passing through walls. These aren't always visible things, but they're absolutely critical for safety. We also look closely at mechanical systems. Confirming the proper installation and function of safety-critical elements like an exhaust range hood directly vented to the exterior to prevent indoor air quality issues, or checking that sealed combustion direct vent gas fireplaces are an acceptable alternative and, more importantly, correctly installed for safe operation and to prevent carbon monoxide hazards. And structurally, things like movement joints. These should provide a complete separation of material and allow free movement while at the same time maintaining the weather tightness of the construction. These are essential in many building materials like brick or concrete, and if they're not properly implemented, you can face future cracking, water penetration, and even structural issues down the line. And for thermal performance, ensuring roof insulation thermal resistance at truss heel should be equal or greater to thermal resistance of exterior wall is vital for energy efficiency and preventing heat loss. So you see, it's really a wide spectrum, from the purely cosmetic, like a paint scuff that just annoys the owner, to functional issues that hinder usability, like that sticking door, and most critically, to performance and code compliance issues that can impact safety and the long-term integrity of the entire structure. Each category, if ignored, chips away at the project's overall value and safety.
Okay, so once this extensive list is compiled, what's the next step? It's not just handed over and forgotten, I assume. The work isn't done yet for the contractor, right?
Not at all. Not by a long shot. The next phase is remediation and reinspection. Once the list is compiled and agreed upon, the contractor's team systematically works through each item. There's scheduling repairs, coordinating the various trades involved, whether it's the painters coming back, the plumbers fixing a leak, or the electrician sorting out a switch. This phase requires clear management, as one source puts it, to work out what the task is, what the objectives are, what the standards are for rectifying each item efficiently and correctly. And after the fixes are supposedly made, the architect and/or the owner reinspects those specific items to verify that they've been satisfactorily addressed. This also reinforces a critical point for contractors. Many contracts explicitly state something like, the architect will not be responsible for work performed prior to approval. This clause effectively puts the onus squarely on the contractor to ensure initial quality and timely corrections, because waiting for the architect to flag it means a delay that's on them.
Got it. And then the grand finale, sign-off and payment. There must be a huge moment for everyone involved, a real turning point after all that effort.
It is absolutely the ultimate goal, the moment everyone has been working towards. The final stage is final sign-off and payment release. The aim is to achieve final sign-off from all parties, formally accepting the project as complete. This is usually tied to a legally defined contract completion date. And this is where the financial pressure really culminates. The at-risk construction manager carries financial liability for bringing the project in on time and within budget. Delays due to unresolved punch list items can be extremely costly. They can lead to penalties or holding back significant portions of payment, sometimes called retainage. So the urgency to resolve them efficiently becomes paramount. You can see why any delays become problematic. If a contract extension might be needed for genuinely unforeseen issues, imagine the added pressure when delays stem from items that really should have been correct initially. The punch list is the final gatekeeper to financial closure, and no one wants to be stuck indefinitely at that gate. Hashtag Tech3. The psychology and friction of the final phase. If we connect this to the bigger picture, the punch list phase isn't just about technicalities. It's really a profound human experience. It's often a crucible of emotions for everyone involved, from the owners who have invested so much financially and emotionally to the last craftsperson on site just trying to wrap things up and move on. It can bring out the best, but sometimes the worst in people, potentially turning collaboration into conflict.
Oh, I can certainly imagine. I remember reading Tracy Kidder's incredible book, House. There's this builder, Jim. He perfectly captures the exasperation that can brew during this stage. There's this fantastic anecdote where, after giving his foundation crew the wrong instructions early in the project, Jim circles a spot where the living room and master bedroom meet. And he laments, "It'll just mean an extra hour in there with a cement drill and a sledge knocking out cement. It's boring. An unbillable byproduct of having this thing wait until the last minute." That just perfectly illustrates the frustration and the financial drain, doesn't it? Time and effort spent on corrective work that adds no new value can't be billed. It's a direct impact of not catching things earlier. It weighs on resources, the schedule, morale. I think anyone who's ever tried to build flat-pack furniture at 2 a.m. and realized they put a piece on backwards knows that exact feeling. That one tiny, infuriating screw that takes longer than the entire rest of the project. Those small, boring tasks at the end become disproportionately irritating, often because they feel like completely avoidable mistakes.
That example perfectly highlights the unbillable byproduct and the inherent frustration. It's not just the direct cost of the rework, it's the opportunity cost, the drain on morale, and that feeling of inefficiency that can just permeate the team, especially when rectifying issues that ideally should have been prevented way earlier. This emotional toll is often underestimated, I think. It can lead to resentment and a lack of motivation to complete those final items with the same care as the initial build.
Yeah, and it's not just internal frustration within the builders team either. This phase can really strain the relationship between the design team and the builders, leading to a natural tendency for blame, right? Kidder's book gives us another great example of this. When revised kitchen plans went missing, leading to a halt in work, Jim and his crew's hilarity and imprecations about architects were apparently quite noticeable. As Judith, the owner, observed, "They love any chance to get mad at Bill, the architect. This time, they're right." It sounds like a powder keg of emotions sometimes. The punch list, being this tangible list of imperfections, can easily devolve into a blame game. It undermines the collaborative spirit that really should carry a project through to completion. The owner in the book, Jonathan, even feels like, "I'm the enemy and I don't think I am the enemy." That really highlights how trust and relationships can erode during this stressful final phase.
Absolutely. And this is exactly why clear lines of authority structure, as Drucker called it, and meticulous adherence to the contract from the very outset are so vital. Without clear roles and responsibilities, ambiguity just fuels conflict.
So the punch list, in a way, is forcing everyone to reconcile their perfect vision with the messy reality of construction. How does that tension often manifest itself?
Well, it really raises an important question about balancing conflicting needs. The PMBOK guide, that's the project management standard, points out this very challenge. It says you need to balance various stakeholder needs and priorities. And when there are multiple stakeholders, especially stakeholders with conflicting needs, it may be necessary to prioritize and make trade-offs. This is exactly what happens with a punch list almost every time. An owner might prioritize aesthetic perfection, demanding every last scuff and uneven paint line be addressed, even if it requires significant effort for a barely visible detail. An architect, on the other hand, might emphasize strict adherence to design intent and specifications, focusing on things that impact long-term performance even if they're hidden. Meanwhile, a contractor naturally prioritizes cost-effective and rapid rectification. They want to close out the project quickly and move on to the next paying job. Reconciling these different perspectives can lead to significant friction if it's not managed with transparent communication and clearly established priorities before the punch list even begins. The perceived value or importance of fixing, say, a tiny scratch, can differ wildly between parties. It can turn what should be a straightforward process into a real negotiation battleground.
Right. Is there ever a point where an owner's pursuit of perfection becomes unreasonable, or is the contractor always obligated to meet every demand, no matter how minor? It sounds like a very fine line. Okay, so if the punch list is such a source of friction, cost, and just plain human frustration, what's the ideal scenario? It's a concept called the zero punch list. It's all about prevention rather than that last-minute cure. It sounds almost mythical, maybe a bit utopian, but it's a very real and achievable aspiration in modern construction, isn't it? Now, the zero punch list doesn't necessarily mean a literal absence of any deficiencies, though that's the ultimate goal, I guess. Rather, it's a strategic shift. It's moving away from reactive correction at the very end of a project to a proactive, continuous process of identifying and fixing issues as they arise throughout the entire construction lifecycle. It's about building quality in from the very beginning, not just inspecting it on at the end. It's a fundamental change in philosophy.
Exactly. And this proactive approach is deeply rooted in lean principles. Lean thinking fundamentally seeks to eliminate waste and optimize value in every single step of the process. The core aim of lean construction is to assure on-time delivery of information and materials to project sites at the least cost and maximum value to the final customer. This means delivering a product that already meets expectations without needing significant last-minute corrections. Think about it like a well-oiled assembly line where every component is checked and verified as it's assembled, not just hoping it all works out at the very end. A key focus of lean is minimizing various forms of waste. Things like low supply and demand reliability, large inventories not needed, and minimal physical waste. From this perspective, a long punch list is, in itself, a significant form of waste. It's waste of time, waste of materials, waste of effort spent on rework. It's essentially creating a backlog of problems that should have been solved much earlier. The zero punch list philosophy directly addresses this. It strives to remove this waste by preventing issues rather than fixing them reactively, saving both time and money in the long run.
Okay, so it's about catching things early, maybe even before they become problems, rather than waiting for them to pile up at the end. It sounds almost too simple, but the execution must be the complex part. How does that work in practice?
Exactly. Early identification and resolution are the cornerstones of this approach. A core lean technique is look-ahead planning. This simply means systematically looking ahead in the schedule, maybe weeks or even months ahead, to identify and remove any obstacles before they can disrupt work and become punch list items down the road. For instance, if you know a particular material delivery is critical for next week's work, you proactively verify its availability now, you track it, rather than discovering it's late when the crew is standing around waiting. This systematic foresight prevents small problems from snowballing into major punch list items by tackling them proactively. Furthermore, the PMBOK guide supports this by advocating for things like tracking feature completion rates. Examining the rate of feature acceptance during frequent reviews can help assess progress and estimate completion dates and costs much more accurately. Regular, frequent quality checks mean fewer surprises and a much more manageable workload at the project's conclusion. And this proactive mindset isn't even new, it aligns with historical wisdom as well. Palladio, the Renaissance architect, in the Four Books of Architecture, highlighted that foundational issues could ruin the whole edifice. And he noted that this danger, therefore, is to be avoided by a trifling expense in piling. A trifling expense up front, like ensuring proper foundation work to prevent catastrophic future failures, is the essence of a zero punch list. It's investing early in quality to save immense costs and headaches later. It's all about foresight and strategic prevention.
Right. And modern technology, particularly building information modeling or BIM, seems like a powerful tool here, a true game changer for achieving this proactive quality control. It sounds like it effectively shrinks the punch list before it even has a chance to grow by moving problem solving from the messy physical site to the clean digital space.
Absolutely. BIM is huge here. Its ability to create a detailed 3D virtual model helps identify coordination conflicts, avoidance, errors, reduction, long before construction even begins. By simulating the entire build in a digital environment, clashes between different systems, the classic example of HVAC ducts running into structural beams or electrical conduits clashing with plumbing pipes, are resolved in the digital realm. This eliminates countless potential punch list items that would otherwise inevitably arise on site, requiring costly and time-consuming rework, often when the building is already enclosed. It's a massive time and cost saver, just that clash detection alone.
And it's not just about clash detection, is it? It's also about communication and collaboration, making sure everyone is literally on the same digital page.
Indeed. BIM facilitates seamless communication and collaboration in a paperless fashion among everyone involved: design consultants, general contractor, and subcontractors. This means issues spotted in the model can be addressed immediately, and changes can be effected and distributed so that steel shop drawings are then produced quickly, for example. It dramatically speeds up problem solving and prevents costly rework out in the field. Imagine the old way. An architect redlines a 2D drawing, sends it back, someone updates it, prints it, distributes it, a process that could easily take days or weeks. With BIM, the model updates automatically, propagating changes across all related drawings and schedules, making the whole process incredibly agile. BIM even allows for accommodating changes later in the process than is possible in standard 2D CAD practice, without incurring massive rework because the model inherently understands how changes in one element affect others. But this also raises an important point about the underlying culture. A zero punch list isn't just about having the right tools and processes. It requires a fundamental shift in how teams approach mistakes and continuous improvement. Without the right culture, even the best technology will fall short.
Okay, so it's not just about what you do, but how you think about doing it and how you interact as a team. That makes sense.
Precisely. A no blame culture is absolutely crucial. As research on lean principles points out, to prevent reoccurrence of breakdowns requires understanding what happened. If people fear punishment, they will not participate in the search for causes and countermeasures. A culture that focuses on learning from mistakes rather than penalizing them is essential for open communication and genuine continuous improvement. This also means challenging assumptions. As the book Sustainable Construction notes, many of the tradition-rooted assumptions used by engineers and architects often result in poor design practices. And challenging these assumptions is important if superior buildings with lower capital costs are the desired outcome. This applies equally to construction processes. Why wait until the end to check quality if you can build it in from the start? It's about continuously asking why and how can we do this better. It's also about systems thinking. Eli Goldratt's book, The Goal, emphasizes optimizing the whole system rather than just individual tasks. He argues, we shouldn't be trying to balance capacity at all, we need excess capacity. The rule we should be following is to balance the flow with demand, not the capacity. Applying this to the punch list means ensuring the flow of work towards completion is balanced, acknowledging that bottlenecks will occur, and planning for them. It means not expecting every single part of the project to run at maximum efficiency all the time, because that often creates unforeseen issues at the end. It's a holistic view of quality, understanding that a small problem in one area can ripple through the entire system and show up unexpectedly on that final list. Hashtag V. Technology's transformative impact on punch lists.
All right, let's turn our attention specifically to how technology is actively reshaping this final, often, let's face it, painful phase of construction. How is it making the punch list process more efficient and maybe even truly collaborative? It's not just about those big, complex BIM models anymore, is it? It's also about everyday tools that are changing the game on site.
Yeah, the biggest shift right now, I think, comes from the proliferation of mobile apps and digital tools. The days of paper checklists, red pens, trying to decipher handwriting, and endless phone tag are rapidly fading. Mobile apps, often running on tablets or smartphones right there on the job site, allow for instant documentation of punch list items. You can snap a photo of a paint imperfection, add detailed notes, precisely tag its location on a digital floor plan using GPS or just tapping the screen, and immediately assign responsibility to a specific subcontractor or individual. This just transforms communication. It enables, as one source said, design consultants to talk to each other and to the general contractor and subcontractors in a paperless fashion. That sounds like it would cut down on a lot of back and forth and clearly delineate who's supposed to do what. It must eliminate those frustrating arguments about who saw what or who was told to fix it.
Absolutely.
Yeah.
It removes so much ambiguity. And not only that, but all parties involved can have real-time access to the punch list, its progress, and any updates. This transparency speeds up the entire process and significantly reduces misunderstandings, which, as we discussed, are often a huge source of friction and delays. Crucially, digital platforms also create an invaluable audit trail. They track who was responsible for what, when it was assigned, when it was completed, even who signed off on it. This fosters transparency, helps manage expectations, and ensures nothing falls through the cracks. Accountability becomes far more robust. No more, "I never got that memo," or "whose job was that?" excuses. It's all logged.
Okay, that makes sense for managing a list itself. Now, going back to BIM, it's clear that BIM is a huge player in the proactive design stage, quality control, identifying conflicts before they even happen. But you're saying its role extends beyond the initial design phase, right? Right into quality assurance for the punch list itself. How does that work?
Precisely. BIM isn't merely a design visualization tool anymore. It's evolved into a living, data-rich model. It can serve as a robust quality control benchmark throughout the entire construction lifecycle, directly feeding into that zero punch list philosophy we talked about. Its power lies in object-based modeling. This allows for modeling of objects first, generic and abstract ones, and later objects corresponding to real products or that will be instructions for construction. What this means is the digital model contains rich, verifiable data about the performance, attributes, and specifications of every single component intended for the building. It goes far beyond just its shape and location. You're not just seeing a digital representation of a wall, you're seeing a wall object with specific insulation values, fire ratings, material properties, even manufacturer data embedded within it. So this detailed product specification then becomes a guide for selecting or constructing the final object. During construction, and especially during final quality checks, this allows for direct digital verification of installed components against their intended specifications in the model. This makes quality control much more objective, thorough, and efficient. Deviations are immediately apparent and can be flagged without subjective interpretation. It starts moving the punch list from a sometimes subjective qualitative exercise, does that look right, to a more quantitative one. Does this installed window match the specified U value in the BIM object? For instance, if the model specifies a certain type of fire-rated door assembly, you can verify its installation against the model's data, ensuring not just that a door is there, but the right door with the right hardware and the right performance characteristics.
Wow, this is really pushing the boundaries. It makes you wonder, could we get to a future where a punch list as we know it barely exists, maybe because buildings are constantly self-monitoring and self-correcting? This seems to align with that vision of sensible cities, doesn't it? It sounds almost like science fiction, but the seeds are already being planted, you're saying.
That's the ultimate aspiration, absolutely. And it ties directly into that convergence of bits and atoms, systems and citizens interacting that defines the idea of sensible cities. In this potential future, buildings might be equipped with advanced sensors and AI that continuously monitor their own performance. Everything from HVAC, efficiency and energy use, to structural integrity via strain gauges, the condition of surface finishes using visual sensors, or even subtle shifts in material properties over time. These systems could proactively flag minor deficiencies automatically, often before they become noticeable to human occupants or require a manual inspection like the traditional punch list walkthrough. This effectively creates an invisible continuous punch list operating in the background, minimizing the need for reactive interventions.
So it's about a building becoming truly intelligent, identifying its own minor flaws before they become major problems, or maybe even before human eye spots them. That's fascinating.
Exactly. Think about the theory of constraints again, that management philosophy from the goal, which focuses on identifying and optimizing the biggest bottleneck in any system to improve overall performance. One compelling example described in the book involved a company proactively managing office supplies for its customers. It wasn't a construction example, but the principle applies. Instead of waiting for customers to call and complain about empty stapler shelves or missing pens, the company took over all this hassle. They ensured the right equipment, the right articles at the right time, replenishing cabinets weekly without the customer even having to ask. This shifted them from being just a reactive supplier to a proactive service provider, eliminating customer frustration before it even arose. So this raises an important question. Could buildings themselves adopt a similar proactive service model? Imagine if the building proactively identifies a minor HVAC filter issue or a paint scuff in a high-traffic area using internal sensors or AI-driven visual inspections, and it automatically generates a work order, maybe even dispatches a pre-approved service team. The focus shifts entirely from fixing what's found at the end of construction to continuously anticipating and maintaining optimal performance throughout the building's entire life. The punch list as a reactive final hurdle could become a relic, replaced by an embedded intelligent system of perpetual quality assurance, ensuring the building is not just completed but perpetually maintained at its peak performance. Hashtag tag outro.
So when you step back and look at it, the punch list, while it might sound like a minor administrative task, maybe just checking off boxes, it's actually a deep dive into fundamental principles of quality control, effective stakeholder management, and the very definition of project completion. It's really where the rubber meets the road, isn't it? Where design meets reality and where expectations are either met or, unfortunately, sometimes fall short. It's a true test of foresight and diligence throughout the entire project.
It is indeed. That journey from 99% to 100% complete, that final push, really reveals whether a project was merely built or truly crafted with an eye toward lasting value and the highest standards. It highlights the importance of every detail, no matter how small it seems at the time, in achieving that final, definitive sense of completion and enduring quality. Consider this wisdom from a book about structures. Even a small crack. Yet it is not really enough by itself to predict the failure of structures. The punch list, in its essence, is about catching those small cracks, those seemingly minor details and omissions that, if left unaddressed, could potentially contribute to much larger issues down the line, issues affecting safety, function, or even just the perception of the entire project's quality. So what might the construction of a future building truly look like where the punch list is not a dreaded final hurdle, but an integrated, invisible, continuous process of assurance? Where from day one, it's not just complete, but genuinely perfect, realizing true project completion in every sense of the word, not just for the first day it opens, but for its entire lifespan.